The James Webb Space Telescope has recently achieved a groundbreaking feat, delivering a view of the universe unlike anything we've ever seen before. This powerful observatory has now focused its extraordinary capabilities on a famous astronomical event, Supernova 1987A. For the first time, we are able to look deep into the heart of this supernova, uncovering structures that have remained hidden from all previous telescopes. When the massive star exploded back in 1987, it became the brightest supernova observed from Earth in nearly 4 centuries. That moment marked a milestone in astronomy. But what we've now discovered using the James Webb Telescope takes our understanding of this cosmic event to an entirely new level. SN 1987A is located around 170,000 light-years away from Earth in the Large Magellanic Cloud. This is a nearby dwarf galaxy that orbits close to our own Milky Way, and it has long fascinated astronomers for its proximity and unique features. The latest image captured by Webb peels back the layers of this stellar explosion to expose a striking structure at its center. What we see is a deep, keyhole-shaped feature shaded in hues of blue. This distinct shape is caused by an incredibly dense cloud of gas and dust, remnants of the explosion itself. The material is so thick and compact that even infrared light, which the James Webb Telescope is specially designed to detect, cannot penetrate it. As a result, this region appears as a dark void in the center, forming a literal and figurative key to unlocking the secrets of the supernova. Inside this darkened core, a bright equatorial ring is clearly visible. This ring wraps around the inner region of the supernova and connects 2 faint hourglass-like structures that extend outward. What's especially fascinating about this ring is its age. It was formed tens of millions of years before the star ever exploded, composed of debris that was gradually shed during the final stages of the star's life. Today, thanks to Webb's incredible resolution, we can see brilliant spots of light dotted along this ring. These are regions where the supernova's shockwave has collided with the older gas, heating and exciting the material, causing it to glow. NASA confirms that these glowing spots are areas where the supernova blast wave, moving at tremendous speed, smashed into the gas that had been expelled millions of years earlier. Interestingly, some of these glowing regions now stretch beyond the main ring, scattering light diffusely into the surrounding area. These expanded regions highlight ongoing collisions between the shockwave and outer material, giving scientists a real-time look into the dynamic aftermath of a star's death. In addition to the ring and hourglass structures, the James Webb Telescope also revealed entirely new features, crescent-shaped formations that had never been seen before. These structures, invisible to the Hubble Space Telescope, are believed to be the outermost layers of gas expelled during the original supernova explosion. NASA noted in its announcement that while the event has been studied for decades, many critical questions remain unanswered, especially when it comes to the neutron star that should have formed as a result of the explosion. The existence and nature of that neutron star are still unknown, but Webb's continuing observations may eventually provide the answers. In another remarkable observation, the James Webb Telescope turned its attention to a different dying star, located within the Saturn Ring Nebula, another site of incredible cosmic drama. This nebula, located about 22,000 light-years from Earth, is among the most beautiful and complex planetary nebulae visible in our sky. It shines brightly enough to be seen with a pair of binoculars on a clear summer night in both the northern and southern hemispheres. However, it's important to point out that this particular observation should not be confused with one of the first public images captured by the Webb telescope. When it launched, the international scientific group known as ESSENCE, composed of astronomers from several countries, was instrumental in identifying the Ring Nebula as a key observation target. Their expertise in studying planetary nebulae made it clear that the Ring Nebula offered a unique opportunity. It fits perfectly within the field of view of Webb's mid-wavelength infrared camera, allowing researchers to examine it in extraordinary detail. This alignment gave scientists an unmatched look into its structure, offering a level of clarity and spatial resolution never achieved before. Using its advanced infrared capabilities, Webb unveiled layers of detail hidden from past instruments. Stationed nearly 1.6 million kilometers from Earth, the telescope was able to spot intricate formations within the nebula that had remained invisible until now. Scientists were amazed at the richness of what they saw. The nebula's iconic ring, bright and well-defined, is made up of approximately 20,000 individual clumps of molecular hydrogen gas, a substance also found here on Earth. This dense molecular gas creates the distinct ring pattern that makes the nebula so recognizable. Within that ring, scientists also detected a narrow band of emission that contains complex carbon-based molecules, including polycyclic aromatic hydrocarbons. This was a surprising discovery, as such compounds weren't expected in this environment. Just outside the central ring, long, thin peaks stretch outward in opposite directions from the nebula's central star. These features are far more visible in infrared images than in those taken by Hubble in visible light. Researchers believe these peaks may be composed of molecules that are forming in denser, darker areas where they are shielded from the intense radiation given off by the dying central star. The ability to detect such phenomena relies on Webb's sensitivity to infrared light, wavelengths that are invisible to the human eye. Further out from the central ring, the telescope discovered about 10 concentric arcs in the nebula's outermost regions, faint, evenly spaced rings that resemble the rings of a tree trunk or ripples in a pond. These arcs were unexpected and puzzling. Based on their spacing, they appear to have formed roughly 280 years ago, during a phase when the central star was shedding its outer layers as it transitioned into a planetary nebula. The regularity and timing of these arcs suggest the involvement of an external influence, possibly a companion star orbiting far from the central star at a distance comparable to Pluto's orbit around our own Sun. As the central star lost mass, this unseen companion may have helped shape these concentric structures. Roger Wesson, an astronomer at Cardiff University, explained that no previous telescope had the required sensitivity and sharpness to detect these subtle features. The James Webb Space Telescope, by contrast, offers a glimpse into the delicate and often overlooked details of stellar death. This isn't the first time Webb has observed the Ring Nebula, but its ongoing observations underscore the importance of this fascinating object and the wealth of knowledge it holds. Historically, the Ring Nebula has served as a symbol of humanity's enduring curiosity and progress in astronomy. First identified in 1779 by astronomers Antoine Darquier de Pellepoix and Charles Messier, who catalogued it while tracking a comet through the constellation Lyra, the nebula was originally misunderstood. It was believed to resemble a planet, which is how it got its classification as a planetary nebula, despite having nothing to do with planets. Over time, as telescopic technology improved, so did our understanding. Today, the Ring Nebula represents the ghost of a star, a glowing shell of gas expelled during its final phases, destined to leave behind a white dwarf. Its vivid structure reminds us that our universe is in constant motion, with stars being born and dying in a cosmic cycle that connects us all. When we study nebulae like this, we are not just looking at distant objects. We're examining the building blocks of the universe, the origin and fate of stars, and potentially the future of our own solar system. In fact, in about 5 billion years, our Sun is expected to undergo a similar transformation, ending its life by casting off its outer layers and forming a planetary nebula of its own. One detail that often puzzles viewers is the unusual colors in the telescope's images. That's because Webb observes the universe in infrared light, which lies beyond the range of human vision. The raw images appear in grayscale until they are processed and translated into visible colors. This process allows scientists to highlight specific features and structures in the nebula, bringing out details that would otherwise remain unseen. With its unmatched ability to peer deep into space and reveal the hidden intricacies of stars, nebulae and galaxies, the James Webb Space Telescope is revolutionizing our understanding of the cosmos. And while these recent discoveries have already stunned the scientific world, we are only at the beginning. The universe still holds countless secrets waiting to be uncovered. So what mysteries will the James Webb Telescope unravel next? Only time will tell.